Welcome to the Section 8 Marathon. 3 factoring problems chain the techniques you have learned this section: GCF, difference of squares, AC method, grouping, and the zero product property. Each problem exercises a different combination, and finishing all 3 confirms the toolkit is ready for the next sections. Problem 1 combines GCF with the difference of squares pattern. Many textbook polynomials have a hidden GCF that, when pulled out first, reveals a clean difference of squares underneath. Skipping the GCF step makes the recognition harder. Doing it first makes the answer obvious. Problem 2 is a trinomial with leading coefficient 6. The AC method finds 2 numbers that split the middle term, and grouping then collapses the 4-term polynomial back into 2 binomial factors. The procedure works for every trinomial, but the search needs the AC product when the leading coefficient is not 1. Problem 3 solves a cubic equation. Move everything to one side so the equation equals 0. Factor the cubic by grouping plus difference of squares, then apply the zero product property. 3 linear factors mean 3 real roots, and the number line shows them at exactly the right positions. Problem 1. Factor 18x squared minus 50 completely. The standard rule says GCF first, so look at the coefficients 18 and 50. Their greatest common divisor is 2. Pulling it out leaves the polynomial 9x squared minus 25. What remains is a 2-term polynomial. 2 terms, both perfect squares, connected by a minus sign. 9x squared is the square of 3x. 25 is the square of 5. Difference of squares applies with a equal to 3x and b equal to 5. Apply the formula and reattach the GCF. 9x squared minus 25 factors as 3x plus 5 times 3x minus 5. With the GCF reattached, the complete factored form is 2 times 3x plus 5 times 3x minus 5. The 2 stays out front, the 2 binomials follow. Problem 2. Factor 6x squared plus 11x minus 10 using the AC method. There is no obvious GCF among 6, 11, and 10, so we move directly to the trinomial procedure. Compute the AC product. 6 times negative 10 is negative 60. We need 2 numbers whose product is negative 60 and sum is 11. Negative product means opposite signs. Positive sum with magnitude 11 points toward a positive value larger than its negative partner. The pair 15 and negative 4 works. Their product is negative 60 and their sum is 11. Use them to split the middle term. 11x becomes 15x minus 4x. Factor by grouping. The first pair 6x squared plus 15x has GCF 3x, leaving 2x plus 5. The second pair negative 4x minus 10 has GCF negative 2, leaving 2x plus 5. Both pairs share the binomial. Pull out the shared binomial. The factored form is 2x plus 5 times 3x minus 2. 2 binomials. The AC method completes the trinomial in 3 lines after the AC pair is found. Problem 3. Solve x cubed minus 2x squared minus 9x plus 18 equals 0. The equation already has 0 on the right, so move directly to factoring the cubic on the left. Group the 4 terms in pairs. The first pair x cubed minus 2x squared shares an x squared, leaving x minus 2. The second pair negative 9x plus 18 shares a negative 9, leaving x minus 2. Both pairs share the binomial. Pull out the common binomial. The cubic becomes x minus 2 times the quantity x squared minus 9. The first factor is linear and ready. The second is a difference of squares. Factor x squared minus 9 as x plus 3 times x minus 3. The complete factorization of the cubic is x minus 2 times x plus 3 times x minus 3, all set equal to 0, 3 linear factors. Apply the zero product property. Each linear factor gives one root. X equals 2, x equals negative 3, and x equals 3. 3 real solutions, one for each linear factor, plotted on the number line at minus 3, 2, and 3. 3 takeaways from the Section 8 Marathon. They cover the 3 branches of factoring you will use in every later section. Always pull out the GCF first before any other technique. Skipping the GCF step is the single most common mistake on factoring problems, and even small GCFs make the leftover polynomial easier to recognize as a known pattern. The AC method handles any trinomial with leading coefficient bigger than 1. Compute a times C, find two numbers with that product and the right sum, split the middle term, and finish by grouping. 5 steps, no exceptions, every trinomial. Solving an equation by factoring is 3 steps. Move everything to one side so the equation equals 0. Factor the polynomial completely. Set each factor equal to 0 and solve those simpler equations. The number of real solutions equals the number of distinct linear factors.